Kia ora koutou katoa, it's Mrs. Goodson here, and this video is about using atomic mass data. We're using it to calculate molar masses and also the number of moles. So when we have a large number of an object, we need quantities that define large numbers. So in chemistry, we use the quantity to describe the amount of a substance called the mole. Not this kind of mole, but it's the number of a substance. So the amount of a substance in mole is represented by the symbol n, lowercase n. For example, if we do little n and then in brackets H2O, this means the amount of water in moles, the amount of water molecules. The mole is defined as the amount of substance which contains the same number of particles, and the particles might be atoms, ions, or molecules, as there are atoms in exactly 12 grams of carbon. So there is a relationship between the mass of the particles and the number of particles. So the mole is the number of particles. A mole always contains 6.02 times 10 to the 23 particles, which obviously is a very, very big number. So this is known as Avogadro's number. It's named after the scientist Avogadro. Its symbol is lowercase n, and its unit is mol, which stands for moles. So there's a couple of videos you can watch about how big is a mole and Happy Mole Day, which is obviously the from 6:02 a.m. on October the 23rd to 6:02 p.m. So just a little bit of fun chemistry humour about Mole Day. So we can, as I said, there is a relationship between the number of moles and the mass of the moles. And we can work out the molar mass, which is the grams per mole. All right, and so this is related to the atomic size. So we can use a periodic table to find out the atomic mass of an atom, and then we can use that to find the molar mass of atoms, ions, or molecules. Okay, so we can use this relationship here. So the molar mass is the grams per mole, or mass over number of moles. So, just a reminder, for all calculations in chemistry, you need to show all your working. This is really important. I know you do this in maths as well. And give answers to 3 significant figures, and make sure always, always, always you have the units with the answer. Okay, so the molar mass of copper sulfate. So in copper sulfate, there is 1 atom of copper, there's 1 atom of sulfur, and there's 4 atoms of oxygen. I hope you can see that. All right, so we use a periodic table to find the atomic mass. So that's the atomic mass of copper plus the atomic mass of sulfur, and 4 times the atomic mass of oxygen gives us a molar mass for copper sulfate of 159.6 grams per mole. Of course, we're not going to round until we get to the final answer. Okay, so it would be 160 grams per mole and for 3 significant figures, but we're going to use this one here to for our further calculations. So we work out the molar mass just by adding together the atomic masses. Sometimes in the question we're given the molar mass, but here's the molar mass for sulfuric acid, which is 98.0 grams per mole. And what that's telling us is that there is 1 mole, so that's 6.02 times 10 to the 23 molecules of sulfuric acid. So in each one there is 2 moles of hydrogen, so the 2 times that would be 12 times 10 to the 23, 1 mole of sulfur atoms, and 4 moles of oxygen atoms. So it just explains the number of particles. But the main thing is to be able to work out the molar mass adding together the atomic masses, because we're going to use this molar mass to work out the number of moles of things. Okay, so if you like to use the triangle, then it's big M times the number of moles gives the mass. The mass divided by the molar mass gives the number of moles. So let's show you an example. So if you have, the question is, what is the mass? So we want to answer in grams, it's telling us. 3 moles of oxygen atoms, and the molar mass of oxygen is 16.0 grams per mole. So we use our equation. So it's number of moles times molar mass, and we get 48 grams. So this is an example of how we can change. We've got 3 moles is 48 grams. All right. So in the lab, of course, it's much more useful to have it in grams because we can sometimes measure out in grams. So this one, we've got an ionic substance, calcium oxide. So we've got the molar mass given to us here, and we've got a value in grams. So this is a little m. So we're going to write a little m next to it because it's grams. All right. This is the big M. We already had the big M there. So we can write our equation, which you were given in the exam on your resource sheet. And then, so we just plug in the numbers. Little m is 94.8. So we put 94.8 divided by 56.1, and we get to three significant figures, 1.69 moles. So the unit for number of moles, little n, is moles, M-O-L. We can also relate this to the concentration of solution. So that's the number, concentration is related to the number of particles per unit volume. All right. So now we have a unit for number of particles. We've got moles. So we've got divided by the unit volume. So we always do volume in liters. So this is concentration is C, so the unit is moles per liter. So we're talking about particles per unit volume. So this is just a way to remember the equations. So you are given this one, number of moles equals mass over big M. All right, so the equation is given on your resource sheet, but this one, concentration equals number of moles divided by volume. This one is not given in your resource sheet. So it's just concentration is particles divided by volume. So this video has been about how to calculate molar masses using atomic mass data, and using this formula, number of moles equals mass divided by molar mass, to calculate the amount, mass, or molar mass. So this is really important, how we can go from grams to moles and back again.